recording. I already talked about the test next week. I talked about, tomorrow morning if you want to come in for tutorials, the quiz tomorrow being over frequency and box and whisker plots. But I also do want to go ahead and remind you of some big events happening next week. How many drills do you have? There are 3 drills next week. Okay, what's happening first period Tuesday? That's a fire drill. Okay, so again, hopefully your teachers are telling you where to go in your first period classes. If not, maybe you could be like, hey, let's say if there was a fire, where would we go? Maybe just got to bring it up in conversation. I don't know. On Wednesday, what's happening during 4th period? That's a lockout. Okay, so that's just business as usual. So the good news is, if we weren't here, we would still continue to do math. I know you're happy. Okay. 7th period, there's a what? Lockdown. Okay, and those are both on Wednesday. That's when, let's say we have one of those in here. We're going to go ahead and kind of huddle over here around Lucas. Okay, there's a lot. This is one of my largest classes, and I know we're going to be really close to each other. So, I do apologize for that, but better to be a little uncomfortable than to have some kind of physical harm happen. We definitely want to be out in front of the doors, out of the line of sight of the windows. Keep your cell phones off, all that good stuff. Does anybody have any questions about that? Have your other teachers started talking to you about what you would do in that class when there's a lockdown? Okay, unfortunately, I'm hearing a few yeses, but unfortunately, I'm still seeing some people shaking their heads no. So maybe the closer we get, that's kind of worrying me a little bit. But any questions about what's happening next week, whether class or on campus? Yes. So this weekend is a normal weekend, but next weekend, everybody gets a 3-day weekend. So it's going to be pretty nice. All right. Well, just to save time, I went ahead, I started it for you yesterday. I kind of got the ball rolling. I said we're going to set one vertex form equal to the other. There were 2 points of intersection, and we were simply looking for the values of x where they intersected. So here's my work. I expanded. Now over here, I had to expand and then distribute the negative. Okay. And then I got it down to this point right here. Well, you'll notice factoring is a great way to solve equations a lot of times. So I just pulled out a GCF. What's that stand for? Greatest common factor. Okay. So 2x times x minus 4 equals 0. For my students I taught last year, what do we call that property? Starts with a Z. The 0? Product property, yes. If you are multiplying 2 items and their product is 0, then either one or both of them equals 0. So that's why over here I said 2x equals 0, x minus 4 equals 0. So those are the 2 locations, as far as x is concerned, where they're going to intersect. Okay. So I don't believe it asked to find the coordinate, did it? It just says find the x coordinates. Okay. So I didn't worry. Now, if I did want to go ahead and find the corresponding y values, what could I do? Where would I plug those x's back in? Yeah, just not necessarily the initial equation, because the equation is created using both of them. So you actually only need one. It doesn't matter which one, because they should give you the same value. Okay. We got that yesterday, so it should be in Tuesday. Should be. Unless they got moved around someplace. Let's see here. Okay, there's the frequency assignment. There's the cumulative frequency. There we go. You got put in. Wait, this day's Thursday. Oh, yeah. So, yeah. There you go. We'll figure out the days of the week. Okay, so any questions on that? Did anybody have that solved? Okay. But more importantly, if you didn't have the opportunity to go ahead and do that, are we okay with it? Does anybody have any questions? Okay. Well, then that takes care of our focus activity. I am planning on giving you your next one probably Monday or Tuesday of next week. Tomorrow, we should be able to just come in, take our quiz, and continue with our lesson. Okay, so speaking of... All right. So our previous lesson, we ended with the box and whisker plots. Okay, so now we're going to go ahead and discuss what's known as cumulative frequency. Okay, cumulative frequency. Well, we got several definitions here, one of which is the cumulative frequency that I just mentioned. So it says the relative frequency of an event is the frequency of that event expressed as a fraction or decimal equivalent of the total frequency. Remember, that's a percentage. Okay. Now, the cumulative frequency, that's what our topic is going to be in this lesson, of an event is the accumulation or sum of the frequencies up to and including that event. That means that's the sum of all the items up to a particular point. This is another way of organizing your data and finding certain percentiles. So when I say percentiles, I mean percentages. In fact, in the first example we're going to go ahead and look at, actually, beyond this one, you're going to be able to see that we can relate it very closely to the box and whisker plots. In fact, since we didn't talk about one of those questions on the homework, if, say, for example, you happen to come across a quiz at some point, maybe in the next day or so, my hints are very subtle, okay? What am I asking you to find when it says determine the 5-point summary? There you go, all 5 of those values. I'm talking the minimum, the maximum, the lower quartile Q sub 1, the median Q sub 2, and the upper quartile Q sub 3. And then it'll ask you to draw the box and whisker plot. Okay, good. Okay, so cumulative frequency, this is going to be an additional column where you simply go ahead and begin adding all the frequencies up to a certain point, okay? Now, I'll tell you what that means, in practice in just a minute. Now, the cumulative relative frequency of an event is the accumulation or sum of the relative frequencies up to and including that event. This is also a percentage, okay? So let's say we have quite a bit of data here. The data listed below gives the lengths of steel rods in meters as produced by a machine. So there's a couple of lengths there, okay? What I'd like you to go ahead and do, the table is already here, so you've got 0.65, 1.25, 1.40 meters, so on and so forth. I want to give you a couple of minutes, and you may not be able to finish the entire thing, but I think, getting practice sorting through data is going to be good. So let me give you 2 minutes. I want you to go ahead and get as far as you can filling out the frequency of each element. So what I mean is, sort through all of these numbers. How many times does 0.65 meters show up? Okay. How many times does 1.25 meters show up? Okay. And then so on and so forth. Okay. Now again, the tally column, I've already filled out the tally column. If you're interested in that, okay, go ahead and fill it out. I'm not too worried about the tally column. So let me go ahead and give you a little bit of time to do that. Bless you. Bless you. Thank you. Okay, so that was not a lot of time, 2 minutes. Most people are probably not done, and that's okay. But let's go ahead and start to look at it together. How many links do I have in this set? How many total links? Oh, well, a little more than 12. Okay, we got 50. 50 total if you look at the entire set of data, right? Okay, so let's go ahead and see if we all agree. So for 0.65, I found 1. Okay. And in fact, I'll just go ahead, do a big reveal. Oh, there we go, like that. Okay. I believe my last one kind of got taken off there, but there should be 11 and then 8 there. There we go. I must have accidentally erased them. Okay, so going down from the top row, I got frequencies of 1, 2, 2, 1, 3, 2, 3, 3, 5, 9, 11, 8 for all the varying lengths. Okay. Are we agreeing? Are we getting something different? Okay. All right. Now you'll notice I've already got these other columns filled in at the very end, the relative frequency and the cumulative relative frequency. Again, those are percentages, but they're not really going to come up a whole lot, or at least I've never seen those appear on a paper exam so far. Okay, so I'm not going to be spending a whole lot of time on those. But what I want to do now is talk about the cumulative frequency. So according to the definition, the cumulative frequency of an event is the accumulation or sum of the frequencies, so I'm adding the frequencies up to and including that event. Okay, so you go ahead and start with the smallest element in your data. In this case, it's 0.65, right? Well, that only occurs one time out of the 50. So my cumulative frequency, I'm always going to start with that frequency, whatever that value is, the smallest element. So now, in order to move on to the next one, I'm going to start taking the sum. So 1 plus 2, whoa, maybe had a seizure for a second. Okay, I'm going to go ahead and add the 2. So 1 plus 2 will give me 3. Actually, I'm going to go ahead and do it on the left side. Okay, and then I'm going to take this current value 3 and add the next frequency value. So 3 plus 2, 5. I see, now the definition is starting to make a little more sense. That's why it's an accumulation of the frequencies up to and including that particular event. Is everybody okay with that? So now I'm going to take 5 and add what? 1, which will give me 6. 6 plus 3, 9 plus 2, plus 3, okay, plus 3, okay, and now plus 5. 20 what? 22. Okay. That's okay. Then 31, 42, and 50.
Do we need to simplify? I'm sorry, I'm getting ahead.
Okay. Oh, yeah, you're okay. I'll talk about that in just a second. And for that, you may or may not want to. I always do, but I always leave the original there, and you'll see why in just a second. Now, take a look at this right here. When you get to the very bottom, that last row, when you go ahead and add the frequency of that final element or number of elements, you'll notice I got 50. Okay. Remember, we started the problem by saying how many elements are in the set. 50. The cumulative frequency should always give you a total equal to the number of elements that you have in your set. Okay. Now, you remember I said that relative and cumulative frequency was a percentage, right? So I was just taking ratios. I wasn't worried about taking the decimal value for these. But you'll notice, if I go ahead and take all these, 1/50ths, 2/50ths, 2/50ths, 1/50ths, if I add them all up, at the bottom there I got 50/50ths. I mean, why does that make sense? What does that represent in terms of a percentage? 100%, because that's all of the data. So that's what you're going to expect to find every time. So Emmy was asking, do we need to go ahead and simplify those? You can if you want to, but if you're going to add or subtract fractions, you got to have a what? A common denominator. That's why I opted, instead of saying, 2/50ths is 1/25ths, I went ahead and just left it as 50 and just combined them all to make them easier. Okay, that's all you got to do in order to find cumulative frequency. You start with the first frequency and you just begin to add the frequencies as you go through the data. Okay, any questions on that? Now, we haven't done anything with it yet. That's just how we find cumulative frequency. Okay, now what did they do at the very bottom? There you go. They took all that data and they went ahead and classified it into intervals for us. Okay. Now, the thing about this, we've already mentioned, the smaller the intervals that you create, okay, the more precise your answers are going to become. So the larger the intervals are that you create, that means your final answers are going to be further from what they really should be. Okay, so it's just kind of something to think about when, say, you're dealing with your internal assessment. If you're collecting data and you decide it's going to be more prudent to divide them into classes, it's usually better to go with smaller class widths than larger. Okay, you're going to get a much better idea of what's going on when you analyze it. Okay, so let's go ahead and do this here. And again, just for the sake of time, I'm not going to worry about this. We're going to go ahead and find all the lengths between 0 and 1, between 1 and 2, and so on and so forth. And this goes back to, sorry, I know it's Ellie or Ella? Ella. I was going to say Ella. Okay. She had asked this question the other day, can data be both discrete and continuous? And again, I want to emphasize, we were looking at all the data itself, which is discrete. We only had the 50 values, but if I go ahead and classify it, then it becomes continuous because it could be any of these. All right, so here is what I found. Okay. Again, just to kind of get the ball rolling, I mean, I know that in a best scenario, I would be able to give you enough time to run through and fill that in yourself, but, you know, we only have about 49 minutes during class. So there was only one length between 0 and 1 meters. There were 5 lengths between 1 and 2 meters, and so on and so forth. Okay. So again, if I add up the total list of all the frequencies, I got 50 elements. Okay. Now, what I want to go ahead and do is take a look at my cumulative frequency. And again, you'll notice I've already taken care of the relative frequency and the cumulative relative frequency. Remember, those are percentages of the data. Okay, but again, I'm not too worried about that. What I want you to do is take about, I don't know, 30 or 45 seconds, fill in this cumulative frequency column. Now, even though I've taken the data and I've divided it up into class intervals, you're still going to do the same thing. Okay, just like we did up here. You're going to start with the very first frequency. Okay, whatever value that is, add the next one, plus the next frequency set, plus the next, and so on until you get to the bottom. Okay, now even though I've divided it up, okay, what should your last value be right here? Should be 50. Okay, should be still 50, even though you divided it into class intervals. Okay, so let me give you a few seconds to go ahead and take a look at that. There you go. Everybody having a good day so far? Tired? Yeah. Probably having a better day now that you're in math?
I have 2 opens next, so yeah.
Wait a minute, you're only excited for math because you are basically out of school once the class is over?
That's a great way to end the day.
That's true. That's true. I'll take it. I'll take it. That's right. That's right. Okay, so let me go ahead and start. Now, I only had one value, a frequency of 1 in the first interval, so I'm going to go ahead and start with 1 right there. Okay. What would be the next value? 6. So I take that value and I add it to the frequency value of the next interval. 1 plus 5, 6. 6 plus 8. 14 plus 3. Plus 14. Okay, plus 19. 50. There we go. That's cumulative frequency. Okay. All right, so like I said, we still haven't done anything with it. I've shown you pretty easily how it is to go ahead and find that sum. Go ahead and get those. So one more thing before I go ahead and get you to an example. This is a frequency histogram. That, I don't know what that is. Take that off. So it says, go ahead and create a frequency histogram of the steel rod data and add a frequency polygon to it. Okay, so why don't we go ahead and do this before we move on with the problem. So we had a length of 0, 1, I think what was it, where did it go all the way up to? 6, okay. So 1, 2, 3, 4, 5, 6. Okay. Now, what we're going to go ahead and do is create a frequency histogram. We're not using the cumulative just yet. We're just going to go ahead and do the frequency. So if I'm looking at the data here, okay, what's the highest value I need to go for in the frequency in the class intervals? 19. Okay, so if I'm looking at my graph right here, I'm definitely not going to be able to count to 19. So what would you like me to do with the tick marks that I have? What do you think would work? Threes? Okay. So I could say 3, 6, 9, 12, 15, 18, 21. Okay. Perfect. I think that makes it fit nicely. Okay. All right. So think about what we've talked about over the previous couple of days. Draw your frequency histogram. Remember, this is one of the activities we did the other day in the calculator. Okay, I showed you how to do that, split screen, all that good stuff. Okay, now because we're going by threes, I'm going to estimate this, so I'll go ahead and catch up to you. Again, probably not done, and that's okay. So between 0 and 1 meters, we had a frequency of 1. So that's going to be a really short bar. Okay. Then between 1 and 2, we had a frequency of 5. So let's say 5 is right about here. Okay. And then we just keep it going. Between 2 and 3, we had 8. So I'm going to get close to 9. Between 3 and 4, we had 3. So that one, get a pretty exact marking on. Then 4 and 5, we're going to go up to 14. So maybe about right there. And between 5 and 6 meters, looks like we're going to end up with 19. So this guy goes the highest. Maybe about right there. Oh, started putting it in the wrong place. There we go. There we go. So I'll probably end up with something that looks like that. Okay. There's my frequency histogram. Is that about what everybody's getting? Okay. All right. Good, good, good. Well, let's take a look at a little bit of information here. Okay, the cumulative frequency curve, this is what we're about to talk about. That was just a frequency histogram. It's used to represent cumulative frequencies, obviously. Since cumulative frequency is the sum of the frequencies up to and including the value being examined, we plot the cumulative frequencies against the upper endpoints of each of the class interval. These points are then joined by a smooth curve. This differs from an ogive curve, which is where the points are joined by straight segments. So normally, I'm always going to go ahead and refer to these as cumulative frequency, but some people are going to go ahead and call them ogive. That's how you pronounce this. It looks like oh give. You know, like what you guys say, oh, give me a break when I say a really corny joke? Okay. But it's actually, oh, why are you laughing more at that than when I actually tell a joke?
Like corny joke inside another.
There you go. Okay.
But it
Okay.
was about corny jokes.
That's okay.
It's like more inception.
There you go. Gotcha. Corn inception. I like that. John Henry, I think you and I are going to get along just fine.
I think we all.
Okay. All right, so it's ogive. All right. Now, the thing about a cumulative frequency curve, it's always going to have like a look of a lazy S. It's in some form or fashion, it's going to look like that. Maybe it's a little steeper, maybe it's a little more horizontal in places, but typically it's going to be a lazy S. Now, how we go ahead and graph these is we take the upper value of the class set that we have, and we go ahead and plot it against the cumulative frequency. Okay. So I kind of ran out of room there writing my ordered pair. So imagine that's an ordered pair. So if I want to go ahead and plot those points, say on a grid, I use the upper value for each class interval, and then I go ahead and plot that against the cumulative frequency for that interval. Okay, so I know that might sound confusing right off the top, but let me show you what I'm referring to. If I come back over here, okay, for this first one, you'll notice the upper class interval is 1. So that ordered pair would be 1, and the cumulative frequency is 1. So that would be the 0.11. Okay. Then the upper class interval for the second one is 2. And then what's the cumulative frequency for that one? 6. So I'd plot the point 26. Does everybody see where I'm getting those ordered pairs from? Okay. So what would be the next one? 314. 314. Then what? 417. Okay. 531. And we'll finish up 650. Okay. Those are the ordered pairs I want to go ahead and plot. Now, if I were to go ahead and plot them and connect them with a smooth curve, that's what we call a cumulative frequency curve, and it's going to look like that lazy S. Now, we're going to come back to this in just a second, okay, because there's quite a bit of information. Remember I said at the very beginning that this is another way to organize the data and determine percentiles. Like you can go ahead and determine which element represents a certain percentage of the set of data that you're talking about. All right, so here you could go ahead and break it up according to your box and whisker plots. 25th percentile, the value has a 25% of the frequencies below it. It's also known as the lower quartile, or Q sub 1. 50th percentile, that's the median. 50% of the frequencies are going to be below it. And the 75th percentile, of course, whatever element you end up with, 75% of the frequencies will be below. That's known as Q sub 3. Okay, so the best way, why don't we go ahead and plot this data? Now, we want to go ahead and plot the lengths, and this is in meters. Okay, remember these are the upper values on the class lengths, and then over here, let's see if I can write this sideways. This is going to be the cumulative frequency. Okay. And here's where I got to make a decision. It's 2 o'clock. We can get these points plotted before we get out of here, right? Yeah, absolutely. Okay. And then we'll probably go ahead and stop there for today, and then we'll start working the actual questions. Okay, so what I'm going to go ahead and do, I'm not going to make the intervals on these the same. You'll notice here, I'm going to go ahead and start here at 0, but I'm going to say this is 1, 2, 3, 4, 5, 6. Okay. So you'll notice along the bottom, I've got all of my class intervals together, between 0 and 1, 1 and 2, and so forth. But as I'm moving vertically, I'm going to go ahead and use each of these little boxes. So like this one would be 5, 10, 15, 20, 25, 30, 35, 40, 45, all the way to 50 at the top. So it works out perfectly. Okay. So you might have to change your intervals occasionally in order to fit all your data on here. So I don't remember off the top of my head. I think the first one was 1, 1. Okay. So I'm going to go ahead and use a different color pen just so we're going to be able to easily see it on here. So the first point was 1, 1. So those 6 points that we just listed, we're now just going to go ahead and plot them. Okay. What was the next one? It was 2, 6. Okay. So I'm going to go 2, 6 up. All right. Then I'm going to go, what was it, 314? 314. Then I'm going to go 417. Okay. Then I'm going to go ahead and say 531. Okay, so I would say right here. And then we're going to finish up 650. All the way at the top. Okay. Okay. And then now let me go ahead and do this with another different color just to make it stand out a little better. Okay, so I'm just going to go ahead and connect these with a smooth curve. There we go. Just like that. There's my cumulative frequency curve. Okay. Now, what I was talking about a second ago, if I were to plot these points, if I were to go ahead and just connect them with straight segments, that's what we call a what? That's an ogive graph. Okay. You're more than welcome to go ahead and do it with a curve or the straight segments. I usually go ahead and just go with the smooth curve. Okay. If your points are correct, you should be getting really close to the answers we need anyway. Okay, so is anybody not sure how I did that? Any questions about anything we've done today? Okay. All right. So I'll tell you what, we'll go ahead and stop there. And then tomorrow, we'll go ahead and immediately begin answering some questions on these, showing you what it can do, and then we'll just see how far we can get. Don't forget, what is happening tomorrow? Your quiz. Quiz. Okay, so if you will put the calculators back in their charging stations, make sure, please put them back in the correct one. They are numbered. Okay. Please.